So today we're going to do precipitation. Right, okay, so we have got our table here, which we need to remember. Now, we've got drops of sodium hydroxide added here, but it actually works with ammonia as well. Okay, so what we've got here is we've got your pale blue solution for your copper 2+. Okay, and then you make your precipitate, your blue precipitate there. Okay, so that's copper 2+, changing into copper hydroxide, and that's whether you add ammonia or you add sodium hydroxide. Okay, so we've added now that ammonia there so you can see. Now, next thing is you've got this, which is chromium, which is your purple, okay, or your violet, sorry, and your violet going to grey-green precipitate, which is dropwise sodium hydroxide. Okay, which you hopefully have seen before as well. Okay, now going towards this grey-green as well, this grey-green that we've talked about, it's a dark green, sorry, that we've all talked about before. Now, next one is iron. So this is iron 2. So in iron 2, if you put sodium hydroxide in, or ammonia, okay, you will get this iron 2 hydroxide, this green precipitate here. Okay, and that's adding it dropwise. Okay, if we carry on, and we move on to the next one, you can see it's starting to go brown on the edge, which is your iron hydroxide, okay, the 3 hydroxide instead of the 2. If you add excess, it just goes all green. And you see as well, it's starting to go brown on the edge. That's why the Fe2, it's just basically oxidizes a little bit further. That's why if you get excess, it oxidizes to the brown, just a little bit, not everywhere. And you can see it's more brown there, okay, after a couple of minutes. Okay, now, if you move on, and let's have a look at these 3 things. So we've got 3 things. We've got iron 2, which is then react with sodium hydroxide dropwise. You get iron 2 and a little bit of iron 3 on the edge. The answer in the exam is iron, this one, the top one. Okay. Then you go from here and you get iron 2 when you've added excess, and again you'll get a little bit of this iron 3, this brown. That's what that brown colour is. Let's put that in. Okay. And let's carry on to the next one. So adding sodium hydroxide to iron 3 this time. And you shouldn't recognise this goes to that brown colour straight away. Okay, and it goes to the brown colour, and then we're going to add excess sodium hydroxide. And if you add excess sodium hydroxide, all that happens is that you get more of your brown precipitate. Okay, and so let's have a look at the 3 versions now. So iron 3+, the precipitate, the brown precipitate, which is iron 3+ with the iron 3 hydroxide. And then again, you get the precipitate iron 3 hydroxide. So that's one of the simpler ones. So we've now got a table building up. Okay. And then let's go to the last one. So this is manganese. My students always laugh at this one because the colours don't look like they are here. That's meant to be a light brown. And that's meant to be pale pink. Okay, so the manganese 2 is pale pink, and that's meant to be light brown. Now, because it's in low concentration, it doesn't really look pale pink, and because of that, it doesn't really look light brown either. Okay, but okay, if we look here, this is meant to be pale pink, and that is meant to be light brown. Okay, so you add a little bit of your sodium hydroxide or your ammonia. Okay, you make your manganese hydroxide, then you add more, and you make a lot more of your precipitate. So then you've got a table like this, which unfortunately you need to remember. Now I recommend one way of doing it is to mix up the table. So here you have the table. Stop the video and try and fill out the table. Okay, I make my students do it in class. So let's go from start. So you've got pale pink to light brown. You have got pale green to a green precipitate, okay, and then turns orange brown in exposure to air. And then you've got the violet going to the grey-green to the dark green. And then you've got the pale yellow, the orange-brown. Okay, and then you've got the blue to the blue precipitate. So there are all your precipitation colours. So precipitation reactions. So questions you're going to get asked. Can you do the equations? We'll do those in a minute. Okay, can you do all the colours? We've got the colours here. Okay, and can you tell me what type of reaction it is? It's precipitation. And remember, it's also due to ammonia. We'll talk about special cases, though, in terms of ammonia in a minute for the chromium and for the copper, because those ligand substitution reactions, end up being ligand substitution. We'll talk about those. The rest of them are just precipitation, but these two can turn into ligand substitution. And we'll talk about that in a minute. So let's have a look at these sodium hydroxide precipitation reactions. Okay, and you look here, and here you have your equations. And here you have your colours. Okay, and they're all the equations that you need. Now, that is fine as well, and the chromium is fine too, okay, for sodium hydroxide. So, but for ammonia, you can still do this. This is the really key thing. You can still do this if you're adding ammonia, but your second, when you add excess, is going to be slightly different, and we'll talk about that in a minute, okay? So if you're just adding a sodium hydroxide, these are all the equations that you need, okay, if you're just adding sodium hydroxide, okay? Now, notice as well, a little one, the last one is not a precipitation reaction because you're making an aqueous solution. All of the rest are precipitation, but it's not precipitation because you're not making a solid, okay? So one exception. Now, let's move on to ligand substitution. Okay, and this is just a reminder, so I'm going to go through this really quick. In the special cases of copper and the special case of chromium, you basically have the same thing, but you're going to need to remember this equation if you add excess. So you're going to have the same equation as you had before for the copper. Copper plus 2OH minus goes to copper hydroxide. And then you're going to have to remember this ligand substitution reaction for ammonia. Okay, now, going pale blue to deep blue. Now, you're going to do exactly the same thing with the chromium, okay, and you're going to have to remember this equation if you add excess ammonia. So it's really important that you recognise that with the special cases of copper and chromium, you're going to need this equation if you add excess ammonia, but if you don't add ammonia, you add sodium hydroxide. It's the equations that we had on the previous slide. So really important, the copper and chromium are just a case for if you add ammonia and excess ammonia. And that's going violet to purple. Now, let's have a look at precipitation reactions with excess ammonia, and you're going to notice something here. Okay, I haven't mentioned the copper and the chromium. So, and these ones are exactly the same as the ones with sodium hydroxide. Okay, the only difference is the ones with chromium and copper, which I've just mentioned. Okay, so really, really important. Now, if that is the case, I hope that sorts out all the different ones that you need and helps. Remember, like, share, and subscribe if you find it of use. And I really thank you for your support in doing that. And I hope this was really helpful.